I'm Robbie Stewart, and I'm an undergraduate with a degree in vertebrate paleontology. We often think of crocodiles as unchanging animals, creatures that are timeless and have existed unchanged since the start of the age of the dinosaurs. But crocodiles actually were completely different from what we think of crocodiles as looking like at the start of the age of dinosaurs when they first evolved. They were also only one part of a gigantic family of crocodilian relatives called pseudosuchians that existed in all kinds of different niches all throughout the Triassic era, which is the start of the age of dinosaurs. There were pseudosuchians with armor who were herbivores called adosaurs. There were two-legged carnivore land-living pseudosuchians called poposaurids. There were sail-backed pseudosuchians called ctenosaurids, some of whom ate plants and some of whom ate meat. And there were two-legged herbivore pseudosuchians with beaks who looked almost identical to dinosaurs, called shuvosaurids. The ancestors of true crocodiles, though, still looked absolutely nothing like any of these other types of groups. Instead, they were small, long-legged creatures with slender bones and strong hips that allowed them to move quickly, climbing, jumping, and running across the land. They had arched backs, and they had specialized hip sockets to allow their leg bones to more securely fit into their pelvis. These crocodilians were small, never more than a meter in length, and all of them would have looked more like reptilian cats or foxes with scales instead of fur than they would have looked like actual modern-day living crocodiles. You would think they'd be completely different animals if you were to look at them alive today. Two examples of these cat-like creatures are Pseudhesperosuchus and Trialestes, a slightly older animal, both from the late Triassic of South America. But while crocodiles as we know them were small, land-bound, insect and small animal-eating creatures, there were creatures patrolling the waterways, attacking animals at the water's edge and eating fish. But they weren't crocodiles. Instead, there were giant amphibians living in the waterways, salamander-like creatures called temnospondyls, that could grow up to 20 feet long and have tusks the same size as a human hand. Creatures like Mastodonsaurus of Germany. And there were also distant relatives of the true crocodiles, another group of pseudosuchians called phytosaurs. These creatures had their nostrils on the top of their head like whales, a blowhole that they could use to breathe while they were underwater. But these creatures were not that closely related to crocodiles. They were only about as closely related as all of the other pseudosuchians that I've mentioned already in the wider family. Some of these phytosaurs could be massive, as big as 8 meters long with a head the size of a human being. These phytosaurs would have been too big to bother with these tiny crocodile ancestors that we're following. But animals in the same group of smaller sizes would have attacked the ancestors of crocodiles in the same way that crocodiles attack people in the modern day. In this time, it was not the crocodiles who were doing the crocodiling, but getting crocodiled. But the days of the phytosaurs were numbered. The Triassic up to this point had been warm and dry, which had allowed pseudosuchians from all over different walks of life to survive alongside the ancestors of crocodiles. But at the end of the Triassic, suddenly this warm, dry period that had led to so many different members of this giant pseudosuchian family suddenly turned cold and stormy, and all of these giant, specialized pseudosuchians suddenly went extinct, leaving only the smallest members of the family, the ancestors of modern crocodiles. During this time, crocodile ancestors had transitioned from being long-legged and slender-bodied to having shorter legs, a less arched back, a shorter, sturdier skull with a wider gape that would have allowed them to open their mouth wider, and a stronger, more well-balanced tail. They also had splayed out claws, And these features suggest to scientists that crocodiles like Protosuchus here would have been semi-aquatic. This is reflective of the entire group's history because crocodiles actually split into many different families who lived many different lifestyles. There are actually 5 different types of true crocodile relatives, all of whom were still around throughout the course of the Mesozoic era. From these semi-aquatic beginnings, crocodiles would radiate into 5 major different families all across the course of the Mesozoic. These different families would adapt to a variety of different niches, on land, in lakes and rivers, and in the oceans. One group wasted no time in adopting the niche that we all expect crocodiles to be in to this day: semi-aquatic ambush predators living at the edge of lakes and rivers to attack prey and feed on fish. But these weren't actually crocodiles. Even still, it was another different group from the ancestors of modern crocodiles that evolved from this common ancestor, Protosuchus. These were called goniopholidans, and they looked almost identical to modern crocodiles, despite not being very closely related. But there were 2 distinct key differences between them and the ancestors of modern crocodiles at this point. They had scutes running down the sides of their bodies, whereas the ancestors of modern crocodiles only had them on top, and they had longer forelegs, whereas the ancestors of crocodiles had longer back legs. The goniopholidans would exist in niches very similar to crocodiles all through the Cretaceous period, before eventually finding competition with true crocodiles themselves. The goniopholidans would spread all through the world of the Mesozoic and live all through the Jurassic period to the very end of the Cretaceous, where they would go extinct during the asteroid strike. Most of them would have looked and behaved very similar to modern-day crocodiles, growing to be at largest about the size of an alligator and at smallest around the size of modern-day dwarf crocodiles. But not all crocodiles entered the niches that we expected. Some of them stayed in the niches that they had been since the Triassic. These animals had long legs tucked under their body for running, and short snouts built for catching insects and small animals. And while they mostly lived from the Jurassic into the early Cretaceous, a relic population of them survived on the islands of Romania. Romania was an island during the Cretaceous, you can see on this map here. Lived on the islands of Romania all the way up to the very end of the dinosaurs when the asteroid struck. And they would have lived like otters, or even like some modern-day crocodiles, like Cuban crocodiles, who live combing the beaches of their habitat, but also will then jump into the water and swim after small animals, being beachcombing scavengers as well as fish-catching animals at the same time. Another group of ocean-going crocodiles were the long-snouted Tethysoukians. These creatures would have had needle-like teeth, long snouts, and powerful tails that would have been able to propel them through the water, living through the oceans of the Jurassic and the Cretaceous. Some of these creatures, called phyllitosaurs, tended to grow gharial-like bulbs on the ends of their snouts. They would have grown to similar sizes as modern-day crocodiles, about 6 meters long, so about the same size as Nile crocodiles and saltwater crocodiles at the largest. But they would have lived entirely at sea, using their paddle-like tails to help them swim. Another way in which phyllitosaurs were different from modern-day crocodiles was in their scutes. In modern-day crocodiles, there's actually a break in the scutes between the neck and the rest of the body. But in phyllitosaurs, the scutes are uninterrupted, going from the neck all the way down the body in this shield-like pattern. One phyllitosaur broke the trend of being an ocean-going, needle-nosed crocodile with a slender snout. Sarcosuchus was a freshwater crocodile that broke the size record of phyllitosaurs, growing to a bus-sized 9 meters long and weighing as much as an Asian elephant. Sarcosuchus had this broad head and these huge jaws at the front, which would have let it catch much, much bigger prey than the small fish that most other phyllitosaurs focused upon. Sarcosuchus was found in the early Cretaceous period lagoons of Morocco and Brazil, living in at a time when these two continents were actually wedged very close to one another, and so they would have lived on either side of the continental divide, swimming through the shallow lagoon formed between them in order to reach either continent. The fish that Sarcosuchus would have been preying on would have been massive. Mawsonia was a fish the size of an elephant, a coelacanth that was absolutely massive and had a gape that could swallow a human whole. And Neoceratodus was a lungfish the size of an American alligator, an absolutely massive creature that would have been a massive food resource for Sarcosuchus. Sarcosuchus was so big that scientists think it may have even been able to attack dinosaurs. But a recent study was done to show that Sarcosuchus was unable to perform a death roll the way that modern crocodiles can. That unified armor plating running from the neck all the way down the back wouldn't have been flexible enough to allow these animals to roll in order to break their prey apart the way modern crocodiles can. Because of this, scientists think that it may not have been able to eat the giant dinosaurs that were all around it. Even still, it would have been one of the largest predators in its environment, rivaled only by theropod dinosaurs like Carcharodontosaurus and Suchomimus. The latest surviving Tethysouchians were a group called Dirosaurids, who were very typical of Tethysouchian lifestyles. They had the long, needle-toothed snout, they had the paddle-like tail, and they would have been ocean-going. But Dirosaurids survived not just past any other type of Tethysouchian, but past most other species of Mesozoic reptiles. Dirosaurids actually survived the Cretaceous extinction event, making it into the Cenozoic, living in the Cenozoic oceans as fish-catching predators. In fact, they even thrived in the Cenozoic oceans, living alongside whales as well as mosasaurs. And the biggest ones actually come from the Cenozoic after their competitors, the mosasaurs, went extinct, growing up to an impressive 9 meters long. What made the Dirosaurids distinct from other Tethysouchians was that they actually had little slots in their skulls where their teeth could interlock as a way to trap fish better. You can see on the skull over here the little grooves in the skull of a Dirosaurid. Because Dirosaurids found more success during the Cenozoic than they did in the Mesozoic, we're actually going to talk more about them in a later video when we cover crocodilians on the other side of the asteroid extinction event and how we got to the crocodiles that we have today. But Dirosaurids were only partially adapted for the oceans. They still had scutes running down the entire length of their back, they still had clawed hands instead of fins. They still had a tail that was long and paddle-like, better for traveling through fresh water than through salt water, and most importantly, they still had to clamber up onto land in order to lay their eggs. So they weren't fully marine creatures. Their hatchlings would have lived on land for the first part of their lives. But one group of crocodilians took the adaptations of living in the oceans to an even greater extreme. Thalattosouchians started to evolve during the Jurassic period to fill the niches left behind by Triassic animals that had lived in the oceans. Ichthyosaurs, nothosaurs, placodonts, creatures that all went extinct at the end of the Triassic extinction with all of their Pseudosouchian competitors. But later Thalattosouchians began to gain even more extreme adaptations to the oceans. You can see how their skin is smooth, not scaly, in order to facilitate traveling through the water. They had short, paddle-shaped fins in place of their claws, and they developed flukes on the ends of their tails. Instead of them being shaped like paddles and having scoots on the end of them, they have these flippers that would have let them propel themselves through the water. Most importantly of all, you can see their hips were actually wider. These creatures had birth canals and gave birth to live young, being the only group of archosaurs, dinosaurs, crocodiles, and pterosaurs, who were so adapted to the oceans that they spent their entire lives in them. Even modern-day penguins, who spend most of their lives at sea, still have to come back onto land in order to lay eggs. But these guys evolved the ability to give birth to live young, being the only members of the entire archosaur superfamily who ever did so. The change was one of the most radical of the Mesozoic, a far cry from what people think of when they think of crocodiles today. Rather than being all the same creatures that had existed the same since the dawn of time, crocodiles had made one of the most radical adaptations of any creature during the Mesozoic, completely dissimilar to the kinds of animals that we expect crocodiles to be today. You can see here, if you were to see these two creatures lined up, you wouldn't think they were close relatives. You'd think that this one was closer to dolphins than it is to crocodiles. But make no mistake, this is a crocodile just the same as this. These highly specialized thalattosuchians were called metriorhynchids, like Metriorhynchus itself right here. And these animals wasted no time in growing to gigantic sizes alongside their cousins, the teleosaurids, who remained fairly similar to modern crocodiles in the way that they looked, or dirosaurids or other ocean-going crocodiles. But both groups grew to absolutely gigantic sizes. Some of them developed broad, short snouts with powerful jaws, perfect for eating marine reptiles instead of fish. While Metriorhynchus has a needle-like snout, this Dacosaurus, which could have been as big as 5 meters long, had huge jaws meant for crushing prey and ripping into other sea animals. The biggest of these was a 6.5-meter giant called Plesiosuchus that was found in the Jurassic of England. But there were some teleosaurs that grew even bigger. The largest of the thalattosuchians was a teleosaurid called Machimosaurus, which existed in the early Cretaceous of Africa. This giant would have grown to over 8 meters long. Whether it was Plesiosuchus or Machimosaurus, the thalattosuchians would have been some of the apex predators in the oceans of the Mesozoic, competing with ichthyosaurs and plesiosaurs, relatives of nothosaurs that had survived the Triassic extinction and started to grow to giant sizes. Some plesiosaurs started to adopt shorter heads with thicker jaws, just like their crocodilian competitors did, forming a group called pliosaurs, which would have been both competitors and potential predators to the Metriorhynchids and the other thalattosuchians. But all of these creatures would end up going extinct at the end of the Cretaceous. The thalattosuchians ended up a victim of their own success, their own adaptations that made them so specialized for the water. During the early Cretaceous, there was an event where the oceans started to drop their oxygen levels, and creatures began to starve from lack of oxygen. This wasn't a problem for the crocodiles since they still had to breathe air, but all of their prey started to die off. And the thalattosuchians were too restricted to the water by this point to be able to come back onto the land. They couldn't clamber back up onto land because of their paddle-shaped fins and their long fluke tails. So they starved to death trapped in the oceans because they adapted too well to their ocean environment. But some crocodiles went in a completely different direction. As we enter into the Cretaceous, we'll talk about ocean-going crocodiles that evolved to replace the thalattosuchians after they died out in the oxygen event, and we'll talk about completely different groups of crocodiles that started to evolve in the late Jurassic all the way through into the Cretaceous, and even further beyond. Some of these crocodile species were so hardy that they even survived the asteroid strike at the end of the dinosaurs. And all of them had adaptations covering land, sea, and river, same as these crocodiles we've been covering so far. And only a very, very small number of them fit the unchanging, ancient creature stereotype that crocodiles are so often branded with.